Hi, my name is Steve Seidensticker, and we're going to talk on this video a little bit about tuning Kadee couplers. If you don't know what a Kadee coupler is, or if you've stumbled upon this video by mistake, let me just start with the basics. Kadee couplers are couplers that model railroaders have used for many years to couple together the cars and the locomotives on their model railroads. Kadee couplers have three things going for them. They look like the real couplers. They allow the coupling of all rolling stock, no matter what manufacturer it comes from, and they allow for prototypic switching operations. I discovered Kadees about 25 years ago. I thought at the time that they were an ingenious design, and I still admire Keith and Dale Edwards' pioneering work. Keith and Dale, Kadee, get it? Over the years, I equipped all my rolling stock on the Gopher Canyon line with Kadees. Most of the couplers worked as they should most of the time, but sometimes they would not uncouple, sometimes they would not couple, and frequently the spotting feature did not work. I like switching, and I host a monthly operating session for local model railroaders. Most of my experience is with number 1 scale, but much of the information presented here is applicable to other scales as well. The basics. The couplers themselves look and work like real knuckle couplers that have been the American railroad standard for over 100 years. From each coupler, a curved piece of steel called the trip pin drops almost to the top of the rails. When the couplers are over the magnet, the magnetic force tends to push the trip pin and the coupler to which it is attached to one side. When there is tension on the couplers, that is, when the train is being pulled across the magnet, nothing happens because the tension on the couplers keeps them from moving. When the coupler is slack, for example, when cars are being pushed, the magnetic force moves the couplers to the side and they separate when one car is pulled away. If the engineer then pushes the cars back together, they will not couple, and the engineer can push the car or string of cars anywhere down the track. This is called spotting. To couple the cars, all an engineer has to do is push the cars together when the couplers are not over a magnet. Let's talk a bit about where to mount the Kadee couplers. You can either mount them on the truck or on the body of the car. Truck mounting is a little easier and is necessary if you have very sharp curves. But if your curves are moderate, I recommend body mounting the Kadees. It's not difficult, it is more realistic, and will provide more reliable operation. The first thing to look at in your tuning or troubleshooting operation is where to place the uncoupling magnets. At the start of my troubleshooting effort, I used one magnet as a reference and test point when tweaking the couplers. After getting all the couplers to work over this magnet, I still noted problems out on the layout. It turned out that some of the magnets were not precisely placed. Number 1, the uncoupling magnet must be centered between the rails. Number 2, the top of the magnet should be flush with the top of the rails. If the magnet sits even 1/16 of an inch low, the magnetic force may not be strong enough to push the trip pin to the side. If the magnet is too high, the motor blocks of locomotives may catch on them, or the trip pins may catch on them. The rails must be perfectly engaged at the magnet. Much of my track is hand laid, and there are a few instances where the gauge is a bit wide. It was not enough to cause derailments, but it did allow some lateral motion that occasionally prevented uncoupling. The magnet must be placed on straight track. This section of track must be long enough to hold both the cars that are being uncoupled. Kadee couplers are not designed to work on curves. The coupler must be mounted at the correct height. The correct height is different for each scale. The instructions that come with each coupler specify the correct height. If the couplers are not all at the correct height, the train will tend to uncouple over uneven track. Also, the couplers will pop open under heavy strains, like if you're pulling a long train up a hill. Kadee sells a tool called a coupler height gauge. This also includes a track gauge and a wheel gauge. There's a different height gauge for each scale. It is an invaluable tool. I use it all the time to check track gauge, wheel gauge, and also helps me center the magnets on the track. Some of the time you may have to carve away a little plastic to mount the coupler high enough, but most of the time you will have to lower it by putting shims between the floor of the car and the coupler. You should never have to bend the trip pin if the coupler is mounted at the correct height. The bottom of the trip pin will be just above the top of the magnet. The couplers must be placed precisely along the center line of the car. If a coupler is off as little as a millimeter, it will not work reliably. Measuring as accurately as you can, mount the coupler using only a single screw in the center. After mounting the coupler, give it a few tests. First, using your finger on the opposite coupler, push the car across the test magnet. The coupler should snap smartly to the right, that is, when you are looking from the back to the front of the car. Next, grab the body of the car and put slight pressure on one rail while rolling the car across the magnet. The coupler should still snap to the right. Next, put slight pressure on the opposite rail while crossing the magnet. The coupler should again move to the right. If the coupler does not move to the side during these tests, there could be several things wrong. It may be that the coupler is not centered properly on the body of the car. The single screw mounting allows fine centerline adjustments by twisting the coupler just a hair. It may be that there is some lateral motion that keeps the coupler from staying in the center. You can feel this by trying to move the car from side to side. Sometimes this motion comes from the attachment of the bolster to the car, but that is usually negligible. Generally, the problem is that the truck frames are too far apart and the axles slide back and forth in the journals. On some cars, there is almost a 1/4 inch play in the axles. The easiest way to correct this is to put washers between the wheels and the truck frames. I use small metal washers with a 1/8 inch center hole. If you are using track power, these washers should be nylon or plastic to prevent potential shorts.